Okay, we'll start with the first tube here, 6SA7. I've already set it for 6SA7, but I want to double check because it's so easy to make a mistake. 6.3 filament, 2 on the signal level, 9L on the bias, and the switches are 27345, 27345, 1650, 1650, 45 on the cheater, meter sensitivity. C for the plate. Okay, 1100 is the reject point. So 1100 is about here, so we want it to come up, up in here somewhere. Okay, we'll pop it in. Give it a moment. First test on most of these tube testers is a test to see if there's any shorts in the tube. A shorted tube is dangerous. In the tube tester, it's dangerous for the tube tester itself. I'm going to rotate this control and watch the meter. It may come up just a tiny amount, or if it comes up any more than a tiny amount, we're in trouble. Nothing wrong. Okay, so we're testing the transconductance. So it's this switch. Here we go. Beautiful. She's a beauty. Okay, that's the first tube done. Okay, next tube is a 6SC7. This is a double diode, double triode rather tube. This is the very special amplifier to run the very sensitive record player. Okay, let's just double check here. 6SC7, 6SC7, 6.3, 2, 20L, 235 GP, 235 GP, 1760, 1760. Okay, we're set. 45. Plate is F. Don't want to make a mistake with this. Don't want to make a mistake with any of these, really. In we go. So I wonder if Grandpa renewed all the tubes after doing that work. Maybe he did. Maybe these are all really low mileage tubes. Okay, short test. No shorts. A lot of tube testers rely on a neon light for this test. They don't actually operate the meter. They just have a light that'll come on. Now this tube, 6SC7, 880. So 880 is about where my finger is. So it needs to be above that. So we'd like it to be up here somewhere. Here we go. Okay, so that's one part of the tube. That's about 1100 as opposed to 880. And it's a two-part tube. So to get to the other, we flip the P1, G1 switch. So P2, G2. Now we're going to test the other half of this two in one tube. Now that's a little low. So according to this, you should throw the tube out if it's less than 880. And we're at 5, 6, 7, 700. And what I like to do in situations like this is play around with this control a little bit to see how sensitive it is. You can get to 880 pretty easily. And this one also, just to see, not so sensitive. It's definitely on 20. So I guess what I would suggest is once we have everything together and we play a record right through this thing the way it's meant to be played, if the volume is a little low, then maybe this tube's indicated. At this point, I wouldn't rush out and replace this tube. Maybe if both sides were below 880. 6SC7. Not sure if I have any of those. I probably do. But that's it for that tube. I'll make a note of that one. 6SC7. Okay, this next tube is a 6SK7. I looked at it. There's no markings on it anywhere. Except a lot of these metal tubes, they'll stamp the tube number right into the base along here. And sure enough, that's where it was. 6SK7. let's check it out here. See if I got this right. 6.3, 2, 10 L, 10 low. 17251. 17251. 4630. 4630. Now, in some tube testers, you can have the tube in, and you can change these. I have another tube tester where the heater selection is kind of separate. Once you have the heater selection done, you can pop the tube and get it warming up while you set the rest of the dials, because no voltages are applied until you push the button. Other tube testers not like that. My recommendation is don't adjust these numbers while the tube is in the socket. Did I check this? 44C. I have done it by accident. I've got a number of tube testers, but one of them for sure. If you start changing these, you can get into a bit of trouble. Not so much again damaging the tube, you're going to damage your tube tester. Don't want that to happen. And by the way, I have quite a number of tubes. I have 4 decent tube testers, and I've monkeyed around with them. Done a lot of comparisons, extensive comparisons at one point, just to convince myself that these things are reliable. And they are. But bear in mind, when you're taking a reading up here, and maybe you're reading GM directly, that's not actually what's happening right now. We're not actually reading the GM with this. I'll explain that in a moment. And you compare it from tube tester to tube tester, and you'll find the same tube reads a different GM in different tube testers. That's not a problem. It's because the different tube testers are applying different voltages, and they're not applying them necessarily the way you might imagine they're being applied. And so it's really the value that the tube tester itself expects on its own meter. You can't compare it from place to place. The GM is dependent upon plate voltage and other stuff. So not so like the guy with more than one watch, you could end up being quite unsure about your tube as you move it around. So okay, we're ready to go here. Right, so shorts. You'd think if there's a shorted tube in that radio, something would happen. Yeah, that's true. It might hum like crazy, or burn out something, burn out a resistor. Something bad would probably happen. So I'd be very surprised if the short test shows a short from tubes out of an operating radio. 6SK7, let's just make sure I'm on the right thing here. So 1520 this time. So 15 is right in the middle here. So it's got to want it up in this area here. Let her rip. There it is. Now if you actually want to measure the GM using this tester, there's a hint down here of what you multiply the reading by to get the true GM reading. Now in this particular tube it happens to be times 1, which means actually this is direct reading. So we just actually measured and read the GM of the tube, which is 2200 on this tube tester. Now what if we look that up in the book? Let's look it up in the book here. Where's the book? Just for fun. We'll take a look. What does the book say? 6SK7. 6SK7. So we look under typical operation, characteristics, transconductance, 2350, 2000. So we're right in the zone there, aren't we? But you see there's two numbers in this book because they're quoting 2 different operating conditions for the tube. So tubes and their circuit have a certain transconductance. Okay, next tube. Okay, next on the hit parade here is a 6SQ7. So let's just check everything. 6.3, we're down to signal level 1. 18 L on the bias. 25100. 25100. 3760. 3760. 37 F 760 is what it wants to come up to, and this again is actually a direct reading of the GM in this tube right on the meter here. So 760 be there. It'd be nice if it's up here somewhere. In you go. Right after I'm finished this, I'm going to jump in my truck and drive to the grocery store. The last time I did that, a couple of days ago, I almost didn't get back because the truck battery gave out the ghost in the parking lot of the grocery store. But since then, I bought a new battery and stuck it in, so hopefully I'll make it back home. That's what I'm hoping. There we go. So what I said it was 760. 760, so somewhere about there. Oh, she's a little low. So this one's reading 550 instead of 760. I'm holding it for a while to see if it's continuing to rise, because sometimes these tubes are slow to heat, but it's not. So this one's a little low too. There's two tests in here. So that's the triode part. That's the part that's amplifying the audio right after detection and sort of setting up the signal to go through the output tube. It's a little weak. Let's check the diodes. So to do that, I'm going to pull it out. Before I change these, I'll just keep the camera rolling. 2013P. 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 This time you can be the double checker. 0760 0760 48 A. P1 and P2. So there's two diodes in here, P1, P2. Remember, in this radio it's only using one of the two diodes. We're good to go. Back in. Maybe in the meantime, while it's warming up, I'll just double check this, just because I get this wrong now and then. 6SQ7 2013P 2013P 0760 0760. Good. Okay. Now we don't use the GM switch. We're going to use this switch. All I got to do is get above me. You probably can't read this on the camera. It says diodes OK right in here. We just got to get up in this range here. We're good. Okay, and we'll check the other one, P2, and check it. About the same. So it could be that this tube is a little weak, and again, if we find out there isn't enough volume coming out of the speaker, this guy could be indicated. What's its future? So how come a tube gets weak? So inside the tube, there's a cathode that's emitting electrons. That particular element has a material on it, a ceramic-like material on it, that helps the cathode emit electrons better than if it were just bare metal. But the problem with that coating is it wears out. It wears out because it's heated up, and I don't know, I guess the electrons happening what they're doing, the electrons are very excited because they're red hot, banging into it, and they literally chemically remove or through that action, as I understand it, they remove the coating. So as the tube is used over time, the coating gets thinner and weaker, and eventually its ability to emit electrons begins to go down, and you get these lower and lower readings. It's just basic wearing out of the tube. As for rejuvenating it, I don't have much faith in that. Is this guy so bad? Well, we've heard the radio operate. The next tube is the Big Daddy. It's the output tube. That's the 6V6. Let's just make sure it is a 6V6 because I can't read this here. Put it under a light over yonder. Yes, 6V6. So it has the correct tube in it. Okay, so I'll get this set up for a 6V6. We'll find out about that key one. Okay, let's find out about this tube. 6V6. 6.3, signal level is 4. That's why, it needs a strong signal on the grid. So remember, the tube ahead of it is a preamp to produce the strong signal for the grid of this tube. 30H, 30, switched it to H. So I guess that means a higher bias voltage, not really sure. 27345, 27345, 0610, 0610, 44, F. We're good. Put them in. You can see the pilot light dim slightly. Why don't we just do a line check here? Because probably tube testing aficionados are upset that I didn't do a line check. If this guy's going to draw a little more current in the heater, right on the money there. Line check is good. Okay, now we'll check it for shorts. You're safe to proceed. 6V6. 1220, this one says times 2. So we're going to look for 1220 on the meter. The actual GM is double that. Well, whatever the reading is double if you want to know what the actual GM is. 1220. So we'd love it to come up in here. Here we go. Oh, she's not so good. So what I do in this case, because we know the radio plays, and we also know that there's something funny going on with the plate voltage being high, the bias voltage doesn't seem right. We're just looking at a worn out tube, or maybe we're looking at a tube that's been worn out by incorrect bias, or who knows. But the first thing I want to do is check to make sure I've got all these settings correct, because I'm going to condemn a tube, especially one that's still working. 30H. 30H. Gotta have these numbers right. 27345. 27345. Because you get these numbers wrong, it's pretty dramatic. 0610. 44 F 1220. Let's try it again here. Okay, now we'll do a sensitivity test. That's actually quite low. Sensitivity tester. I like to do this just to find out, I haven't got this set right on the money. Is that why it looks bad? I don't think so. The bias one hardly doing anything here. So I think we probably do have a legitimately weak output tube. And this is a hard-working stereo and amplifier, because look at the size of that speaker there. That speaker's hungry. So typically, we're going to test one more tube, I think. Typically, the hard-working tubes are the ones that wear out. Of course, the output tube is hard-working. So, why didn't they just design it heavier? Just make it a heavier tube. Well, we have trouble selling the more expensive tube when a cheaper tube can get away with it. Repair guys like the weaker tube because they get to come in your house and repair it. A little bit of heat in here still. Expect these to get warm. Never so hot you can't touch them, that's for sure. So I think I looked at this earlier, 5Y4. Let's check it, because this is also a hard working tube. It's probably the hardest working tube in there. So we'll set up for a 5Y4 here. Okay, I think we're ready to go. Now, when you look in this tube, you look inside the tube, you can see it's actually two separate things inside there. It's actually two things in there. Yeah. So it needs two tube tests, but they're identical things. Before I plug it in, let's just double check. 5Y4. So the 5 is a hint at what the supply voltage is. It should be 5. So I've set this to 5 down from 6.3. 0030P. 0030P. 0760. 0760. 25 E. Bias doesn't matter. Signal level doesn't matter on this kind of tube. It's just a rectifier. Now there's a note here, F. What F is saying is to expect a short to be found during the short test, usually on setting number 1. And then P1 and P2 has to test the two parts of the tube, plate 1 and plate 2. We're good to go. Watch the pilot light. See what happens. See that dim way down? So part of making this tube able to conduct a lot of current, because it's actually supplying the current for all the other tubes. You know, the current that's going through the cathode plate circuit and all the other tubes. So it's doing a lot of work. You want a hot, ow, got a muscle spasm in my neck here from doing this. You want a really hot tube so it can emit as much electrons as possible. And I'm not sure, but I don't think this has a coated cathode. It may not even have a cathode. The electrons may come right off the hot elements in here. I'm not sure. Different tubes work different ways. So let's see for that short. Here we go. There it is. Not a concern. Now this is a rectifier tube, so rectifiers and diodes. In this case, the rectifier OK is marked here. So anywhere above where my finger is now, my fingernail. We are good. Here we go. So it's in the good range. Now we'll change to the other plate. Test the other half. Well, it's not way in the good, but it's in the good. Again, the radio's working. Voltages were high. Put a better tube in, the voltages are only going to go higher yet in the radio. I'm pretty sure. So I don't think there's anything here to jump up and down about. The only thing that's really come out of this, I think, is that there's a series of tubes in the audio amplification chain that are all a little bit weak. And so, you know, weakness adds to weakness adds to weakness. But until we get everything in here, record player and all, power it all up and operate it, we can't be completely sure about that. And even that's a bit of a judgment. I mean, how loud is loud enough? You're trying to fill an auditorium with this thing? I don't think so. Just trying to fill a room in your house. Okay, so what's left to do on this guy is the alignment, followed by the final test. I'm out of time here. Got to head off to the grocery store and try to get back from it. So thanks a lot for watching this video up to this point. This guy's in great shape. I think it's going to sound fantastic once it's all together, and that's what we'll try to do tomorrow. So see you tomorrow. Well, hi, good morning. Thanks a lot for joining me here. Yes, another day's gone by. The tube testing was actually done yesterday. And here I am today. It's now the 29th of January. Boy, oh boy, is it cold here. Beautiful blue sky again today. Beautiful sunrise, but it's minus 30 outside to start. If you're American, minus 30 is about 20 below zero. That is really cold here. Minus 20 is a cold day here. Minus 30, oh my gosh, that's crazy cold. So, but beautiful looking outside, and I feel sorry for all those who are on the east coast of the United States, in the New England area, who are being battered by a gigantic storm, which is just kind of get going there. So. Well, the weather this whole winter has, instead of crossing through Canada in my area, I mean the snow type weather, it's all gone south. And what we've got here is polar air all the time, but clear skies. And there certainly is snow on the ground here too, and it's not going anywhere. That kind of cold temperatures. Now, what I'm going to be doing today is I'm going to check the alignment of the radio. Chances are the radio is aligned quite well because it operates. We've heard it receive stuff. No reason to think it's way out of alignment. The challenge here for me is the radio is not in the cabinet. If it's not in the cabinet, it doesn't have the glass dial face. I can't be absolutely sure where the radio is tuned. When I was reading the instructions here, I noticed, this is the table of alignment activities. Down here is a little note indicator, and when I read the note, it says accessible through side of radio compartment when pulled forward. So these are the two trimmers that are mounted on the side of the tuning capacitor. Here on my bench, they're right here and here. I thought, really? These are accessible through the cabinet? Let me take a look at it. So here's the cabinet. Pull it open, and lo and behold, there are two holes in the side here. You put your screwdriver or alignment tool through and try to hit the screws that would be hidden from view in there. So that's how they've accommodated the problem of trying to align this radio. I'm not going to do that. The owner has told me he's not terribly interested in the radio part of this, and part of that is because I told him don't be too interested in the radio. Part of this AM radio, for a radio like this, wow, what are you going to hear? You're going to hear your computer wailing away just like we hear it here in the shop. So the AM radio is not very important to the owner. I certainly understand that. So we're not going to spend a lot of time on this. I'm going to peak this guy for performance. It's going to be close to what the dial shows. I'm pretty sure of that. So I've got the radio tuned to the far end here, and I'm pretty sure that would be 530 is where it's tuned now. Anywhere else on the dial is a bit of a guesswork. Even at the top it's probably 1600 right at the top, but it may not be. But we'll start here and assume that that's 530. That means the capacitor is completely closed. And another thing is the instructions are often written as if the radio is way out of alignment. So you're starting way out in center field, and you're going to try to get the home base. You have to go through maybe a stage by stage approach. Get the second IF stage tuned up. Get the first IF stage tuned up. Here, step 3, you can't read this. Step 3 says, with test oscillator connected to 6 SA7 grid, peak C7, C6, C5, and C4, which are the same 4 capacitors that are in the top of these cans. So what they're saying is, hook your signal generator to this tube, adjust this can, hook to this tube, adjust this can, and then with it still adjusted, still connected here, adjust both of them again. So I'm just going to skip the first part because I don't think it's necessary at all. I can do the second part. But you don't have to make a direct connection to the grid here. The grid of that tube is connected to the antenna. So what I'm going to try to do is feed my signal generator signal right into the antenna. Now there's my signal generator there. This big old military guy that I like using so much. And right above it is a frequency counter, so we know exactly what frequency this guy's tuned to. To do the IF, it needs to be tuned to 460, so we will do that. There we are, practically there right now. How do you like that? Okay, my counter's just a wee bit low, so that's 460. So now we have a 460 signal coming out of this cable, going just to this simple, few turns of wire. You can see the radio antenna sitting there. I'm just going to put it right on top. That should put enough signal into the antenna here that some of it's going to get to the radio. Now the radio antenna is tuned to 530, not 460, but 460, 530, not too far apart. I would be really surprised if I can't pump some of that IF frequency into the radio. Another thing that I need to do here, what I like to do is use my SDR radio. SDR radio is this little box over here. It's a software-defined radio. Its signal processing is done using computer software, not using complex circuits like in this radio. And I can use that to pick up the local oscillator, which is usually quite strong in these radios and easily picked up. So the antenna to the SDR is just on this, another very simple coil, and I just put it in the vicinity of where I believe that signal exists. It's going to be around this capacitor and around the tube. I'm just throwing it around the tube. Yes, it's a metal tube. I'm just putting it there to start with. The oscillator coil is underneath the radio. We can even get it near that. Not so close that it influences it, but near it. So we should be able to see the actual local oscillator frequency, which is something that could never be done back in the day when people were doing this back in the 50s and 60s, repairing these radios. So that's a huge advantage in doing an alignment. So the main objective here is to get the radio's performance as high as possible. You can judge the performance by listening to the tone coming out of the speaker, or we can put it on a voltmeter, measure it, and then we get a visual indication. Now this is where these older indicating meters really work well with pointers on them instead of a digital meter. This is tricky to do with a digital meter because it's refreshing its numbers periodically. It's just uncomfortable to do it that way. I would like to use that meter you see right here, but this one gives me just enough trouble. I'm just going to stay away from it. I'm going to bring another meter into play here up above my shelf. Down you come. So there's two approaches that can be taken. The recommended approach for this radio is to hook the meter up to the speaker. So whatever signal gets to the speaker shows up on the meter. The problem with that is you have to listen to the speaker. It could be the case that that's a little uncomfortable. And another approach is to hook up a good high impedance meter, like this guy, to the AVC in the radio. Difficulty with using that technique is to generate an AVC voltage, you have to have some significant amount of signal going through the radio. And it's best to do alignments with the minimum amount of signal going through the radio. I'm generally fairly lackadaisical about this. I like using the AVC myself, simply because we don't have to listen to the speaker. We just keep the volume turned right down and just watch the AVC. But let's start with what they say. We'll hook this meter up to the speaker here, and we'll go from there. I also have to let the radio warm up, so why don't we turn it on, and then I can go for a coffee break. What? Coffee break already? There we go. And now because the radio's performance is pretty good already, it's a little bit far-fetched that I'm going to peak it up a significant amount. I think I'm just going to turn off this light here if I can. There. But I enjoy doing this part, and I would feel remiss if I didn't go through this process a little bit with the radio. It doesn't have any bearing on playing a record. That's what the owner's really intent on, of course, playing records. We will get to that. Once the alignment's done, I'm hoping today there'll be enough time left for me to bring the record player back in, up on my bench, get it all plugged together, and see how loud the record player is. When I did the tube testing, a couple of tubes came up a little weak. Those are the audio tubes, especially the preamp tube for the record player. So when we tested it before, I took the output of the record player and fed it straight into the my audio system here. So we didn't use this guy, so we don't know how well this guy works yet. And so there might be a couple of tubes that need to be replaced. I have replacements for them. Okay. We're on the phone right now, aren't we? Let's go on the radio. What's all that? That is probably because I am right now feeding a signal in to the antenna at this frequency. Let's knock this way out of here for a moment. I'll just change bands here. Oop, let's go even higher. Okay, so whatever's coming out of the signal generator won't affect it. Let's see, can you still hear that? That swooshy sound? No. Wow. Okay, so some radios can make this exact sound when they're out of sorts. It's called motor boating. But I don't think that's what this is. I think this is an actual interference signal here in my shop today. I get this ticking signal. If you've watched my videos, oh my, what's going on there? You know that I do get an interference in here that sounds like that. Coming back. Let's look this. Oh, so you can hear it in this radio too. What exactly this is, I don't know. Goodness knows I have hunted around for it, but very hard to localize something like that. And I think the reason is often these interferences in our house are traveling around in the house wiring system, and that pretty much makes it impossible to try to locate it. So but that's what that is. That's external interference. Antenna's not in a very appropriate location here, but certainly the radio is working. So we're just gonna close it down again. Okay, I'm gonna let everything warm up for a bit and go have a little bit of coffee, and then we'll get going on this. Okay, let's start with taking a look at the SDR frequency display here. And what should stand out is this line and this line, and there's more of these up this way we can't see right now. This red line is the tuning indicator for the SDR itself. So if I click somewhere, the red line will jump. So this is not a received signal in any way. But I can use this to really get a grip on what frequency is right here. You can see it's 991. Now this is going to be shrunk down on the screen momentarily. It'll be very hard for you to see these numbers, but I can tell you what they are. So I'm showing you this so you have an idea of what's really on here. Okay, now what happens if I tune the radio? So I'm just going to tune the radio. It's at 530 right now, conceivably. We're just going to tune it up. Okay, and you see that that line is moving upwards. The reason it's dipping down each time I tune a bit is the SDR is doing that. The SDR is trying to process these signals. It's just an artifact of the SDR. But if I stop tuning, you can see there it is. So where is it now? It's roughly, or precisely, at 1,046,000 kilohertz. 1,046,000 hertz, rather. So this is the signal, the local oscillator signal that the radio generates to mix with the antenna signal, and then the difference frequency, if it happens to be 460, will go through the IF and come out the speaker. So we can look at this by saying something like, so this is what the radio is attempting to receive. We take this frequency and subtract from it 460. We haven't checked to make sure the IF is at 460, but we will very shortly. So if we subtract 460, so what I'm going to do, I'm going to make this easy on myself. 460, I'm going to put this up to 1060. And I'm going to tune the radio to move the local oscillator there. Local oscillator is now running at 1060. We subtract 460, we get 600. So this radio is tuned to 600. If I went down just like this, let's just try this. And I tune the local oscillator. Just a little experiment here. Radio is now attempting to receive 590, and there's a station at 590. So why don't we have a listen? I'm going to flip back to the other camera here. Or to the camera. Or to the camera rather. And there we have up on the left is the same display you were looking at now. Turn up the volume a bit. Oh, Son of a gun. Okay, now I'm going to manipulate the antenna and see if that station comes in. There it is. That's a very good indication that the radio's aligned quite well. That's a very, very strong indication that it's aligned quite well. Let me turn the volume down here a bit. Okay, so we're going to proceed now, but I really am convinced that it's well aligned. But let's go ahead. So the thing to do now is to push into the radio a 460 kilohertz signal. Let me just adjust the lighting here a little bit. Maybe I'll kill that completely. There we go. Okay, well, so we'll make this say 460. That's 460, even though it says 459. We should hear a tone coming out of here, as I have the modulation on over here. That's a what do we get? Nothing much. So this is a suggestion that the IFs are not tuned to 460, but that's a little surprising considering what I just did. So perhaps there's not enough signal generator signal getting into the radio yet. So we're going to crank it up. It shouldn't matter where I'm tuned. I just want to be tuned somewhere quiet. Right here. Let me crank up the output here. Well, it sounds like there's no modulation here. Why would that be? The switch was not quite set right over there. Okay, so way too much signal. Way too much modulation. Put the modulation about 30%. Knock the signal way down. There we are. Now, the objective is to raise the level of this. Get it on the meter here. Pointer's just there. Let me vary the volume and see if that for sure is what we're dealing with. Okay. Likewise, I'm going to vary the signal strength of the signal generator and make sure that the meter does move when I do that. Let's get close to the antenna. I'm not sure why it's doing what it's doing, but I'll stand still. Yeah, that's for sure without a doubt, that's a signal generator. Right down near the bottom of this meter, but this is a decibel meter, that's not zero. There's no zero on a decibel meter. Well, yeah, that's not quite true. Zero in the sense of nothing. Now, how stable is this? Not terribly stable. I'm not moving at all, and it's kind of going up and down a bit. See if we can just locate that quickly. Just going to wiggle a few of the tubes here. Try not to burn my fingers. Don't touch the output tube. Okay, we're going to give the radio a bit of a rough treatment here. That made the burned out light come on. It wasn't burned out. Let me turn this guy off too. I just assumed this light was burned out. Okay. Thumbs up for Grandpa, who probably put new lights in it too. Okay. First we want to find out, is this really 460 that the radio's tuned to? I'm going to vary this frequency a little bit. I'm going to watch the meter and see if it goes up or down or what it does. There we go. I guess my arm is influencing this arrangement here somehow. I don't know. There we go. Down. Up. So what's happened here is Grandpa did his best. but he's aligned the radio at 455 when the instructions say 460. How big a deal is that? It's not a big deal, but it's a simple thing to put it to where it should be. What it would do is slightly influence the tracking of the pointer and maybe lead to a little bit of confusion in doing the alignment. 455 is the most common IF frequency, but 460 is quite common too. So we're going to move this to 460. Curious that when I did the check with the SDR, it seemed to indicate 460 was golden, but let's do that. We'll put this up to 460. Right there. Turn the volume up a little bit. Now the objective is for me to adjust these adjustments. These adjustment screws. Bring this meter up. That's what we're going to do. Make myself a nice tool here. In this case I'm using a very stiff piece of plastic, but often I'm using metal screwdrivers to do this. If these are capacitors in here, it's usually okay to do that. Let's see if this will even fit. Kinda. I'll try this plastic one. The problem with plastic is it can twist. Hear it and we can see it on the meter. It's right at the bottom of the meter, but that's okay. Try this one here. Yeah, so my tool is twisting rather than turning the screw. There it goes. The screw is stuck there a little bit. Another thing about doing this is pushing downwards on the screw can move it, change its setting, so to speak. You get okay. Started with the IF transformer that's closest to the speaker. Now we'll go back and do this other one. I think we're going to see a bigger change here. Oh yeah. Looks like these transformers were not aligned to the same thing. Okay, I'm going to do this last trimmer. So I'm going to switch to a metal screwdriver because there's too much twisting going on. So pick something here. I'll use my antique. We'll repeat them all. Turn the volume down a little bit. Now, typically you do this with the volume turned right up. Let me turn this down. Weaken the signal. Turn the volume up. At some point, the noise we're hearing is going to be louder than the signal. So to verify that's not the case, I'm going to vary the tone level. See it there? So the noise is not interfering. There we go. Well, it's wandering around a lot. Of course, because I'm doing this myself, and I sort of have a tactile knowledge of what I'm doing, of course, I'm listening to the volume too. higher there a moment ago, but it's moving around for various reasons. So I'm to tune the signal generator, and we'll see if in fact it's loudest here. So we'll go down, and we'll go up from here. Yeah. Highest place on the meter is perfect. Okay, so that's fairly minor adjustment. Most radios like this require a minor adjustment. The only reason they'd be way out is because somebody didn't know what they were doing and they twiddled those things to death. Seems to me I did that when I was a kid. Now the next two steps don't involve the IF frequency, the 460. They involve actual radio frequencies. That's where the SDR is going to come in fairly handy. So let's take a look at the instructions. It says, using a radiation loop, which is what I'm using here, 1500 kilohertz, so we start at the top. Tune the radio to 1500 kilohertz. Now, how do we know it's at 1500 kilohertz? Because I can see the local oscillator frequency on the SDR. So I don't need the scale. This is not exactly the perfect way to do this, but it's a way. So we'll tune up to 1500, so that would put the local oscillator at 1960. 1960. But then we're adjusting the oscillator trimmer. Well, that's not going to work out all that well. So the adjustment to the oscillator trimmer is about making the pointer line up with the dial. And we're not going to be able to quite do that. But what we can do is we can do the other. I have no reason to think that the dial is way off. I don't really know. But no reason to think it's way off. We could tune this to the minimum, assume it's 530, and then check to see if that's correct. We can do that. We can do that easy enough. Go up to 1500, we'll go up to the 1960 local oscillator frequency, and then we'll adjust C2, the antenna trimmer. See how that works out. So let's go down first. Okay, that's the end of the road there. So what I'm going to do is take a look at the frequency of the local oscillator now. I'll just click on it here. 990. If you subtract 990, if you subtract 460 from 990, you get 530. So maybe that's absolutely true then. The capacitor, when it's fully closed, the radio is tuned to 530. Great. Now we'll go up. We want to go up until the local oscillator is at 1960, wasn't it? So we'll just go up, 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 up. 1960 is going to be right around here. Now we'll measure it. 1919. So we'll set this to 1960. So the radio is now ready to receive any signal at 1500. So we can check that by giving it a signal at 1500 and just see if this is working out. 1500. So you can hear the interference of the signal coming through. Let me just turn it up a little bit. It's dead on. Can't be too surprising. The local oscillator is set at a certain spot. The IF frequency has been set to 460. It can't not work. Let's put it that way. If it didn't work, you scratch my head. Is this really pointing at 1500 on the dial? We can't really tell right now. Okay, so now we're going to adjust the antenna tuning adjustment. I think the antenna's probably interfered with this coil. We're going to move this. I hear a pretty distinct hum coming through the radio. I'm just kind of hang it up here somewhere. I hang it right there. Okay, we'll tune this guy in. Give a little more power. More power. not working out. Maybe the angles here are no good. It's got to be more like this. And have these things at right angles. They don't interact very much. Let me get a spacer here. Just a cardboard box. Keep it down. So the swooshy sounds in that is because there's stuff being received by the radio, noises being received by the antenna, and the mixing these two things together is causing the funny swooshy sounds. Well, let's see if we can make it stronger now. So just to double check, make sure I don't get it wrong. This page doesn't really show which trimmer is which, but I'm pretty sure I know. Trimmer on the bigger part of the capacitor is going to be the guy. This usually doesn't make a lot of difference. This is just about making it stronger or weaker. Can't tell what's going on here. Getting weaker now as I clamp it down. Never a very distinct peak on these, I don't think. I think that's it. I think that's the best we can do for the radio. Didn't do much. Could be the two IF transformers were actually tuned to two different frequencies, so maybe the performance of the radio was suppressed a little bit. We're going to find out now. So first I'm going to switch this way up high, so it can't interfere. Hang the antenna back up in the air. Kind of no way of doing that. Okay, we've got some wires here. Kind of hanging there. Still too low. Let's go higher. There it is. Okay, so we're going to go hunting for some radio stations. Sounds to me like a volume dependent hum here. Let's tune a bit. Well, it could be part of what we're receiving here. Okay, chances are we only receive stuff down here, maybe in the middle. Is the antenna in a good direction? I don't know. There's the French station. This is a really good test station. Reception is excellent.
Comment vous avez débuté la démarche? Emmenez-nous dans vos coulisses. Là.
Oui. Par exemple, j'ai reçu.
Yeah, I've done many radios. This one is working really well.
Une photo qui était prise juste.
We should probably pick up some more stations, maybe 840.
That number to call is 1-800-212-4181.
extra strength glucosamine pain relief formula.
Glucosamine. I don't think that was 84.
Period of time. So it's not like we've got 8 years and this thing changes. Right. But to the greater question, the reality is we're more ready as an infrastructure capability technological than most people believe. The greatest problem that I find is not that we have an infrastructure problem or a capability problem. We have a thinking problem. There still is a lot of old ideas permeating out there, some led by, colleagues of mine who've been,
I don't know where that's coming from. Picking up lots of stations here.
Snow up in this country tomorrow, expected Terry down the stroke and very brief. And then for Monday, -3.
This may not all be Canadian. It could be picking up an American station. A little odd during the day, but can happen.
Had to go through a few appeals over the years to make sure the benefits continue. This time around, though, I told her she shouldn't bother with another appeal since the insurance company is insisting she can do
Sounds
another
excellent.
job at a
moral imperative to talk about these things I'm talking about. Is the next round in Washington. They have done the same thing for truckers at the borders. Yeah, there's truckers lining up at the borders. I mistakenly was researching truckers on my Facebook, so the algorithm is now...
Truckers.
Must be kind of up and down. And that's Stafford. He's always been all up and down. What we're really seeing this year is how high the ups are. We know that because he won so many games with the Lions that were generally a terrible organization. Now we're seeing that. Now we're perceiving how good he can be and maybe how good he could have been, yes, if he spent 10 years at an organization.
That's the end of the road there. So this is probably 590 here.
I came by that honestly. So.
In those codes. And I have no idea why you would hire a defensive first coach if you're the
talking about
Bears when you have a young quarterback with a ton of talent.
This is the strongest station I can get here in my shop. Some radios, this is just about it. I only get this guy. So excellent job done, Grandpa. Mostly thank you, Grandpa, for the excellent work done. Okay, so next step now is to get the record player back in here, plug it in, see how strong the record player is, because there's a preamp tube in here which is doing nothing right now, and the preamp tube measured weak on my somewhat weak on my tube tester. So it's interesting to see just what kind of volume we're going to get out of the record player. So I'm going to shut off just about everything and get the record player set up here. Wonderful.